All of you join fast. Ajad. So we'll start with the problems of shaper. Before that, we have to just go through the derivation, estimation of the machining time of shaper. So all that it is necessary. So what is the machining time? All of you listen. What is the machining time? I think the audio is okay. It's clear. Ajad.
Yes, sir.
Okay. Try to because we are thinking that some disturbance in the net. Okay. So here, ask your people to join fast, because if you start at 9, you'll be joining at 9:15, and we start at 9:15, we'll join at 9:30. Okay. So I'll start the lesson. So here, the time required. What is the machining time of shaper? So the time required to complete the work, so that can be obtained. So when the length of the cutting stroke, the width or length of the workpiece, width is given by B. So width is given by W, the length of the workpiece. Length of the workpiece, already I told you, it is given by L, and capital L is given by the length of cutting stroke. So capital L is the length of cutting stroke in meters, L is the length of workpiece in meters, and W is the width of workpiece in meters. So just the units are very much necessary. So already I told you. So what is the cutting speed in the return direction, return stroke, and the cutting speed in the forward stroke also has to be considered. So here S1 is the average cutting speed in meters per minute. Average cutting speed in meters per minute. S2 is the average return speed in meters per minute. So first we have to predefine the notations or parameters for the derivation. So in the earlier diagram, when we have discussed in the shaper, so L is the distance to be traveled before cutting. So we just try to place the tool on the at a small distance from the job. Okay, so that is the L1. So what is L2? After machining, you have to just or travel distance. So what is the thing? L2 is the distance traveled by the tool beyond the work surface. Beyond the work surface. So that is the thing. And already I told you some relation is there. We'll just try to discuss that also, as far as L1, L2, and L1, L, capital L is equal to some relation is there. We'll try to discuss. So N is equal to number of cycles. So what is the number of cycles? Already I told you, in one particular single pass, we cannot perform the machining operation. So the final, until we get the final size of the job or workpiece. So we have to go for a number of cycles. What is F? F is speed per cycle in mm. What is m? So in some of the, don't worry about the notations. Standard, we are using the standard notations, but in some of the textbooks, instead of m, it may give k or something. So stick to that. Stick to standard notations. M is equal to ratio between the return time and cutting time. So what is M? Ratio between the return time and cutting time. So what is cutting speed in the forward stroke? So length of cutting stroke by time taken in cutting stroke. So this derivation is of very much importance. Either you may give the derivation of the problem as far as the third unit is concerned, the first half. So what is cutting speed? What is the cutting speed S1 we have seen? So in the forward stroke or the cutting stroke. So what is cutting time? What is cutting time or the machining time? It is the length of cutting stroke by cutting speed. So all these are very much necessary. So it is, what is the length of cutting stroke? Already we have predefined. It is capital L. Beware of the capital letters and small letters, because it is not case sensitive, the derivation. You have to use capital L, small l, L1, L2. So you have to know what are the parameters which we predefined. So what is cutting time is equal to length of cutting stroke L by what is cutting speed? S1. S1 is the average cutting speed in meters per minute. So that is the in the forward direction. So what is the L by S1? What is L? What is L? L is equal to L plus L1 plus L2. So I may have written, just try to observe the derivation also. L plus L1 plus L2. So what is the non-cutting time? Non-cutting time is the return time or the return stroke. That will be idle without without performing the machining operation or the cutting operation. We just try to have that non-cutting time or idle time. This is the length of stroke by return speed. Length of stroke is given by capital L by S2. S2 is the return speed. So just try to have that. So what is that length of stroke? It is L plus L1 plus L2 by S2. So what is the total time? Total time is the addition of the cutting time plus non-cutting time, or the machining time plus non-machining time. So what is the total time? Total time per cycle. So total time per cycle is cutting time plus ideal time. So cutting time is the forward stroke and the ideal time is the return stroke. So if you remember like that also, you can easily cutting time. What is the formula? L by S1. So what is the non-cutting time or idle time? L by S2. So it is given by this, okay, but here he has added a constant. Why he has added, I'll try to tell you, L by S1, but L by S2 can be written in terms of C into L by S1. So what is that C? C is the ratio of ideal stroke time. So just try to remember, because here people try to commit mistakes as far as the problem is concerned. So C is equal to ratio of ideal stroke time to cutting stroke. Ratio of return stroke time to the cutting stroke time. So that is very much important. So just try to observe. So what is total time required? L by S1 plus C into L by S1. So that C, noted down, and then some of the problems will directly give as 1 by 4 or 1:4 or some ratio. So you have to 1 by 4 is 0.25. Like that you have to calculate. So, and this is L into, so if you try to take L common, it is 1 plus C by S1. So that is the total time required. So what is the shaping width? So just try to see, because so many parameters are here. So shaping width is given by width of workpiece. You just try to remember width of workpiece, what we have defined. So still people are talking. I have to mute. Every time I'm telling, you are not listening, and you are in a very confused state now. All the exams are coming. Be attentive. Make your mind clear. So shaping width B is equal to width of workpiece plus 2 into allowance plus twice into. This is the formula that is given. So that is there's a standard formula that you have to adopt for this derivation. So what is the number of cycles required? Already I told you, it's given by N. It is the shaping width by feet per cycle. So what is the shaping width? It is given by B. What is the feet per cycle? Feet per cycle is given by F. So N, number of cycles required is given by shaping width by feet per cycle. So it is N is equal to shaping width B by F. So what is the machining time now? So machining time, already I told you, you have to take a number of cycles. So machining time can be calculated as number of cycles into time required for each cycle. So what is that machining time? Number of cycles. How many number of cycles are there? That much number into what is the time required for each cycle. So we'll try to tabulate what is the number of cycles. It is B by F. So what is the time required for each cycle? So we just calculate or tabulated there, or we have derived L into 1 plus C by S1. Because what is the time required? L by S1 by L by S2. But what we have written L by S2, we have written as C into L by S1, that L by S2. So that is the important thing you have to remember, and we have to just say this, just combine this B by F into L into 1 plus C by S1. So already I told you what is C here. C is the ratio of return stroke to cutting stroke. Return stroke, mostly it is named as ideal stroke, but because the machining is not done, it is known as the ideal stroke. So what is this total formula? L into B into 1 plus C by F into S1. What is F? F is speed per cycle. Speed per cycle. So that is the derivation you have to take into consideration, because you may give the metal removal rate problems of formulas. You just try to remember, but here the derivation of the machining time is very much important. So we'll try to repeat after the two problems, because in one of the PPTs we have a basic problem. Before that, I thought I want to just go for the derivation of the machining time, because this is a problem on shaper. Because in this particular unit, we have problems on shaper and as well as drilling also. So the drilling is the next part, drilling and boring is the next part of this unit, which we may start on Monday's class. So you just try to see the change in timetable. 9:15, 10:15, 11:15, 3 hours in the morning. If you have 4 hours, the fourth hour will be shifted to 2 o'clock, 2 to 2:50. So just try to observe the timetables. Okay. So what is the problem now we have to consider based on the machining time? We'll just try to see. So all of you just try to take the problem. So I'll just read. A cast iron plate is measuring 300 mm into 100 mm into 40 mm. Is to be rough shaped along its wider face. Just try to remember. So what is the first one? L, length of plate. Second one is width of plate. So all that you have to take into consideration. The other one, L into B into T. So simply, and or L into W into T. So because B, we are taking the width of the, what we have taken here, you just try to remember, because you don't try to just shaping width. The capital B I have taken shaping width. And don't use small b here also. The standard notations are L, W and T thickness. So it is to be rough shaped along its wider face. So he is asking us to calculate the machining time, taking approach time, taking the approach as 25 mm. I'll just try to approach is what is approach? Approach is the 25 mm. Over travel is 25 mm. So what you have to take, I'll just try to explain you, but you have to take the cutting speed as 12 meters per minute. The forward stroke, the return speed in the return stroke is 20 meters per minute. And allowance, he has given allowance. Already I told you that allowance we have to take into consideration. And on either side of the plate, he has given some allowance as 5 mm. And what is the feet per cycle? F. F is given by here in the notation you have seen. F is the feet per cycle. It is given as 1 mm. So all that is very much necessary. So what is the length of plate? L is equal to 300 mm. What is the width of plate? W 100 mm. So what is the approach? 25 mm. Approach and our travel is given same 25 mm. But what is cutting speed? We have specified that clearly in the derivation S1. S1 is 12 meters per minute. So what is the return speed? Return speed is S2. S2 is equal to 20 meters per minute. He has given in the. So what you have to do? Some people try to write without writing the given data again. In a hurry, they try to write, but that is not a good presentation as far as the problem is concerned. People may argue, what is the presentation of the problem? The steps will try to give you some marks, even if the particular calculation mistake or some particular mistake is there with the calculator or some particular. So you just try to observe the protocol or the sequence of steps. Given data, you have to write. So what is the allowance on width of plate? Allowance on the width of plate is given by 5 mm. You just try to listen carefully because these problems are given earlier in the sets as far as JNT is concerned. So what is the feed? Feed per cycle. Feed is given by 1 mm. Feed is given by 1 mm. So what is the length of stroke? Already I told you. Length of stroke is equal to length of plate into approach. Approach L1 plus L2. Length of stroke is equal to length of plate plus approach. What is approach here? Approach will be in mm. Or travel will be mm because you place the tool just before the job in order to start the machining cycle or the machining of the job on the shaper machine. So that is very important. Or travel, you just don't try to take the tool just after it finish the edge of the workpiece. You have to, because it will rub, you have to go for some over travel distance, whatever is given the problem, you try to take. That is, so length of plate plus approach plus over travel. This over travel is very much necessary in shaper machine. So this is 300, length of plate is 300, or approach is 25, or travel is same 25. So that it is left over with 350 mm. So conversion of units are very much necessary. So what is 1 meter? 1 meter is equal to 1000 mm because in this generation you are not worrying about the units. You are not conscious of the units, so be careful. We were thinking that the master is very much whatever every time is telling, okay, నాకు తెలిసిందే చెప్తాడు అనే feeling ఉండదు. If you have that feeling, nobody can learn new things. This is not a new thing, but new subjects, new topics in all the subsequent semesters. So cutting stroke time. So what is cutting stroke time? It is capital L by S1. So already I told you, you have to be very much conscious about the capital letters and small letters used in the derivation. So it is L is equal to 0.35 by what is S1? S1 is the cutting speed in the forward stroke. It is 12 meters per minute. So you just write that. So this is meters per minute. So the cutting stroke time is given in meters. So you just try to calculate whether you are getting that or not. So I'll try to display this for some few minutes, or after finishing of all the three, if you want me to repeat, I'll repeat, because you are very much lazy in joining the class. I'm seeing you are joining. I already told you 9 o'clock class, 9:15, 9:15 class, 9:30. It's not for you. It is for the convenience of the faculty, because the stability of the network has to be checked in the college before resuming the class. So ideal stroke time is equal to L by S2. L by S2. What is L? Yeah, already we have calculated 0.35. What is S2? It is the return speed in this meters per minute, 20. So it is in minutes. So just try to see whether you have got this or not. I think all of you are just using the textbook and pen for the problems, or else I'll try to just keep you, I'll be sharing all that, because yesterday I've shared to A sections here, B sections here, and some person was very much interested. It's not that we are showing partiality. The CRs will try to share that in the WhatsApp group, and some of the students are very much eager. I share to them. So we are very much free to just contact via the WhatsApp. Okay. So as far as any material or any doubt is concerned. So time per cycle, L by S1 plus L by S2. So here he has given directly, because he has not given C there. See the ratio. That's why we are not writing L by S2 in terms of C into L by S1. Here we are directly applying whatever given data that is given in the problem. So time per cycle is equal to L by S1 plus L by S2. So you sum up both these values, you'll be getting this value, this value. So just try to be conscious. Don't be stingy in using the calculator. I've seen so many people that don't know how to use the calculator while calculating the angles also. In the lab, we try to ask them, they'll be having many maths doubts. So, what is shaping width? Shaping width is given by capital B. So shaping width is given by width plus twice into allowance. Why we have written twice allowance here? You try to see in the problem. So you try to see in the problem what he has given in the problem. Allowance has to be on either side of the plate, either side of the cast iron plate. Whatever material is there, we will be specifying. But here, uh, in the theory, we are not worried about the material, because in the practicals only, according to the material only, we'll try to use the type of tool suitable to that particular job piece material or the work piece material. So you have to be conscious of these things. So what is the time per cycle? Already we have seen shaping width plus twice into allowance plus 2 into 5. You have to take the allowance on either side of the plate. So 100 plus 25. So it is 110. So all this are very much necessary. Why am I repeating? Though is not asking nowadays in some of the sets, but we have to consider all the sets and try to just deliver the syllabus to 100%, all the 6 units, all the topics. So n is equal to number of cycles. So it is capital B by F. So what is capital B? Shaping width. What is F? Feet per cycle. So feet per cycle is simply given only a single cycle, 110 by 1. So 110 cycles we have. So what is the machining time? What is the formula for machining time? What is the formula for machining time? It is the number of cycles into time for each cycle. Time for each cycle. So what is the particular number of cycles? We have calculated 110. So what is the time that is calculated for each cycle? For the forward stroke and the return stroke, we have considered. So that is 110 into 0.0466. So you can just give this machining time as TM, because the standard notation is that in some of the textbooks he has not given. You simply just write equal to and just tabulate and calculate 5.126 minutes. This is very much required. So today we have covered the derivation for machining time and done a problem. As for the application of the derivation, we have applied the problem. We have applied the derivation in the problem. So similar type of problems may be asked. You don't worry, you have to worry about the academics, but nowadays people are not worried about any further studies as far as the PG is concerned. But nowadays you have to, without PG or any qualification, higher qualification, because of the dearth of jobs in the industry, you have to improve your skills as far as the other aspects are concerned. So just try to see the soft skills or whatever the skill development centers in the college. So I just spoke to you in the second year. So I'm just close to section B, because I have not taught anything about Belgian lab in section A. So it's not that now both section A and section B I'm teaching. I have to tell them the importance of all the skill development centers, the Assault Lab, Belgium, Siemens. So just try to improve. Okay. So time and again, I'm not only the subject, we have to teach the particular things you have to follow. So still some people are just not mute the particular phones or whatever it is. So just every time have to go for mute all. So what is the second problem? Second problem is related to calculate the machining time required for machining a surface 600 mm. So what is 600 mm? It is the length of the job. In some of the problems, He'll be writing some notations like J, this is a subscript, J, LJ, length of the job, width of the job, B or BJ. But you don't have to write this, but just for the sake of some notations that are followed in the standard textbooks or some of the material, you just try to have this notations, follow this notation, 600 mm into 800 mm, length into width on a shaping machine. So you just try to see, is not taking the thickness into consideration, but as far as the other things are concerned, we have to, sometimes in some of the problems is just giving the length and width of the job. Okay, so assume the cutting speed as 8 meters per minute. So V is the cutting speed. So what is the return stroke to cutting time ratio? So every time that is very much required. So sometimes it's giving us K, sometimes it's giving us C. So just try to see. But the ratio, it is not opposite. It is not cutting time to return time. It is a return to cutting time. So that you have to consider. So because here one means it is speedily coming without machining the return stroke because of the quick return motion mechanism that is induced in the shaper. That is, we follow in the shaper that is designed for the shaper. So it is 1 by 4, 0.25. So what is speed? Ikkada జాగ్రత్తగా చూసుకోండి. Speed is given by 2 mm per double stroke. So that is the thing he has given. So double stroke. So that you can take it. And what is clearance? Clearance is given directly as 70 mm. So what is the time required? He is asking what is the machining time required. So what is the machining time required for machining a surface on the shaping machine? So what is the formula? Directly we have gone for the formula. It is L into B into 1 plus C, or sometimes he will be giving K. So you can use either notations, either K or C, but you try to follow carefully. So that is very much important. So 1000 into V into F. This is a formula which just try to use when only the single cutting speed, only a single value of cutting speed is given in the problem. L into B, length of the job into width of the job, plus 1 plus K. What is K here? K is the ratio of the return to cutting time ratio. So it is the time ratio, 1000 V, F. V is the cutting speed. F is what? F is the double stroke. So just try to see here where stroke length. Why we have taken 2 here? Why? Because clearance has to be given on both sides of the job. So we have taken twice here. And here it is 600 plus 2 into 70. 2 into 70. What is the stroke length? L is equal to Lj plus 2C. That's why they have written, or simply in some of the textbooks he has given Lj as simply small l. So you try to follow standard notations because if you have to follow, if you're easily following in the class, only if you see once, it will be, you'll get into your mind, or try to do as many problems as possible. So from P.N. Rao or this Kaushish or the Hajara Chaudhary or Raghuvanshi. So I think by this time you are well aware of the whatever the textbooks we are following. So what is T? T is the machining time, or we can write simply as not capital T, TM also. So just try to follow standard notations. What is the L? L here, you just try to be careful. If you are writing L in the problem here, without calculating the stroke length, you are in trouble. L is here the length of the stroke length of the stroke, 740. If you are writing some simply, I am telling all these people try to commit mistakes here. So suppose you are writing the length of the job, which is given as 600, I think. So if you are writing there the length of the job 600, you are out. So whole problem. Some won't see the procedure, some won't see the procedure, some will directly see the this answer and try to award marks. So you will be getting 0. Whatever if so is a short answer, 2 or 3 marks, you will get getting 0. If it is a big one also, you will be getting out of 7 0. So try to follow stroke length LJ plus 2C, because you have to give whenever you are considering clearance has to be taken on both sides of the job, the workpiece of the job, whatever material, irrespective of the material. Because already I told you, whenever we are considering the material, we have to take the tool according to the cutting material. Okay. So it is 740 into width of the is 800 and 1 plus 0.25 by 1000 into 8 cutting speed into feed double stroke. ఇక్కడ వచ్చింది చూడండి, ఇక్కడ 1 తీసుకుంటే ఇక్కడ 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 మీరు సింగిల్ వాల్యూ ఎఫ్ ఇస్ ఈక్వల్ టు 2 mm పర్ డబుల్ స్ట్రోక్ ఇచ్చారు, పర్వాలేదు. బట్ వాడు ఎక్కడ ఒక మెలిక్ పెట్టి మనకి సింగిల్ స్ట్రోక్ అని మనకి వాడికి కావాల్సిందే డబుల్ స్ట్రోక్ అంటే మనం 2 mm తీసుకోవాలి. 2 mm డైరెక్ట్గా ఇచ్చాడు కాబట్టి సరిపోయింది. ఒక కాంపిటేటివ్ ఎగ్జామ్స్లో ఇన్ కాంపిటేటివ్ ఎగ్జామ్స్ ఇట్ ఈస్ రైటింగ్ only one here, instead of the using the double stroke, you will be in trouble. So this is 2 directly as given, but sometimes you will be giving a single stroke and you have to take that as double. Okay, for that particular problem. So this is T is equal to machining time 7,40,000 by 60,000. It is as simple a problem as it is. It is as simple a problem as it is. So you have to be very careful in your presentation of the problem also, because I already told you about the different way of correction. So I want to ask you now. So anybody just unmute yourself other than Ajad, and shall we repeat the derivation or go for the next problem in one of the PPTs? Ajad? Ajad? Okay.
Sir, sir.
So ask any one of the participants. Durgarao is there? Pandapalli Durgarao? So don't try to leave the meeting, because I'm observing 99, 97, sir. So shall we repeat the derivation or go to the next problem? One of you tell. One of you speak out.
Yes,
Durgarao?
sir. Sir.
Shall we repeat the derivation or go to the next problem?
Go to the next problem, sir.
Okay. I'll just stop this here, and if you're having any theory or problem, we'll just try to discuss in one of the PPTs. So we'll try to go for the new share. So just try to be quiet, or as far as this one is concerned. So can you see the screen now?
Yes, sir.
Okay. So now it is related to some. I already told you this M is taking some MK or something. You don't worry about that. You just try to know the concept. So already we have seen this particular derivation, where we have now done the one problem related to this LB. Here sometimes yes, taking W and B. Don't worry about that, but stick to the standard notations. Here he has taken from the cutting speed, the machining time. What is the time required to complete one double stroke? Because it is a double stroke, you have to not take a single stroke. So here T is equal to L into 1 plus some K or M. So 1000 V, that is common. V is a standard notation for the cutting speed. So what is the number of cycles, the number of double strokes or cycles is given as ns, W by B or B by F. This B is the width of the workpiece, shape width. So this is the total time for machining Tm or T is LW. In the standard notations, we are taken L into B into 1 plus M or 1 plus K. What is K? Ratio, the time ratio of the return time to the cutting time. So you have to take that 1:4 means 1:4 or 1 is to some 1:2 or some 2:3. That particular values you have to take as given in the formula. So that's why I want to just show you this also, because people may confuse as far as why I have come, because I want to just cover this material removal rate also. Material removal rate sometimes is giving the short answers and the big ones, but you have to be very careful of the conscious of the units. But if you want to write that particular the time in the time of ramp strokes, that capital N, this is the formula you have to adopt. The time in terms of ramp strokes N, the time for machining surface is given by Ts is equal to W width by F. F is speed into N, and N is the number of ramp strokes. So that is very much required. So that is the formulas you have to say. Already I shared this. You just try to see. I think the CRs also have to be prompt in sharing to the group. So if anybody are finding it difficult, you can contact via WhatsApp. So material removal rate. Material removal rate is given by F into D. What is F? F is mm per stroke. What is D? D is depth of cut. What is N? Ramp strokes. N in strokes per minute. What is L? L is the length of stroke N mm into 1 plus M or 1 plus K. This is the formula. We will be giving you small problem, and directly you apply the formula as far as the material removal rate in shaper. So that is very important. F, D and L. Like you just try to have the notations carefully and into 1 plus M. So because it is material removal rate, the volume of metal removed per minute, it is given in cube, volume, cubic units. So you have to be very conscious of the units also. So you be careful, okay? So that is the thing you have to see, and we'll see if any particular problem is there. I just seen, but we just try to, in this 12 minutes, we just try to discuss something that is related. Just try to see, because so many PDFs or PFs are there. Sometimes it is difficult to, okay. So already we have seen this also. Shall we start this particular thing also we have seen the difference between the planing machine and shaping machine. So already we have seen the first one, tool reciprocates and the work is stationary in shaping machine, and the planing machine, the work reciprocates and tool is stationary. In the shaping machine, the machine is used for machining medium and small workpieces, and the planing machine, it is used for machining large and heavy workpieces. All this we have seen, just is a repetition. So less accuracy because overhanging of ram, overhanging beam, just like overhanging beam, it is more accurate planing because it is rigidly supported on both the columns. So both double-sided planer. So it gives more accuracy as far as the tool is rigidly fitted or supported during cutting. So that is very important. So the production time is less because in shaping operation, in shaping machine, we have two or four tool heads. We have seen in the basic shaper, that is the universal shaper, we have seen. So the production, ask your parents to not to talk in between. So what is the production time? Production time is more because we have a single tool head in planing machine. In the production time is less because we have 2 or 4 tool heads. So what is the shaping? Shaping, we have the work setting is easier, and work setting requires more skill. Here semi-skill, or here also semi-skill, but more skill than this particular person, machinist. But everything depends upon the training the machinist will get. Okay, so heavy cuts cannot be given on the shaping machine, and heavy cuts can be given because it has a rigid base. Rigid base, that is a machine bed, and you're using superior tools or precision tools in the planing machine. It's not that you're not using shaping machine precision tools, but more when that is a comparative degree. So all that we have seen. So all this we have seen. So just try to just go for the penny. Okay. So this is the problem I was speaking about. Okay. We have luckily found out. So what is the machining time? You just try to see. It may be similar things as far as whatever we have discussed earlier. Maybe, but we'll just a sort of repetition here. Yeah, the same problem I think, but just try to have this problem again. So find the machining time required for machining a surface 600 into 800 mm on a shaping machine. So just try to see L into length into width. Assume cutting speed V 8 mm per 8 meters per minute. So sometimes this particular ratio is given to fool the students in some way, but you have to take that as every time the ratio is returned to cutting time. Don't take as 4:1. 4:1 means 4 because it is in decimals actually 1/4, 1/3, or whatever it is 2/4 or 3/4 or whatever it is. It's not more value than 1. The value is not more than 1. So the ratio. The feed is 2 mm per double stroke. Here the clearance he has given. So the clearance at each end is you have to take into consideration and you have to calculate that value. So what is LJ? Same. Maybe this was taken. I have not seen this, but I have taken on one of the sets and solved there. LJ. This LJ 600 mm, W is 800 mm, V M is equal to 1/4 0.25, F is speed per double stroke 200 mm per stroke, C is equal to 70 mm. So just try to see in earlier whatever PPTs, if any problems are there, just try to concentrate or in the textbooks. So length of stroke is equal to LJ, length of the job plus twice, because you have to take the clearance on both sides of the job 2 to 770, same 740, same data is given there. Okay, may not have seen there. So 700 into the length into width 700. If I already told you have to take this the length of the stroke, not the length of the job. So 740 into 800 into 1 plus 0.25. 1K. This is the ratio of the return stroke to cutting time. So 1000 into V into F. So that is 46.25. So this is one of the problems you have to see, and you have to be very careful as far as the units are concerned and the allowances are concerned, the clearances are concerned. The second problem we just try to see. So he is asking us to determine the material removal rate, assuming the depth of cut as 4 mm. So all the other things are same. He is given is a different problem though. He has given the length of the cast iron workpiece. He has given the width of the piece. He has given the cutting time to return time ratio 3:2. Just try to see every time the ratios may not be given same, but how you take this in the problem is very important. So that is 3:2, and the cutting speed he has given as 21 V, 21 meters per minute. Feed he has given as 2 mm per stroke. Here he has given 200 per stroke, not double stroke. So you have to be careful there. And clearance to 25 mm. So the available ram stroke he has given. So what are the available ram strokes? He has given 28, 40, 60, and 90 strokes per minute. He has given 4 values. We'll just try to see how we apply that in the problem. So also determine the MRR, material removal rate. The depth of cut you have to take as 4 mm. So all that, what is LJ? LJ is the length of the job. F is equal to 2 mm per double stroke. Though you may not given 2 mm here, single stroke you have to take in the F is equal to, in the formula, F 2 mm per double stroke. Though you have missed there the typing or something, you have to be very careful there. the double stroke. The width is 150. C, clearance. V, cutting speed. D, what is D here? You just try to see depth of cut. Depth of cut is 4 mm. So just try to see. Small d is not diameter. Depth of cut. So as far as here. So what is the cutting to return ratio? 3:2. ఇక్కడ చూడండి మీరు 3/2 వేసి ఇక్కడ 1.5 అన్నారు అనుకోండి m. అందుకే చెప్పా ఒక్కొక్కసారి you will be giving in the opposite sense, opposite ratio. So you have to take that as not 3/2, 2/3. 2/3 is 0.66. You have to be very careful. Suppose he is giving here other way, the standard notation you have to follow for this m, the return to cutting time ratio. Return to, this is the return, this is the cutting time. So what is L? Length of stroke, length of the job plus twice into clearance, clearance 25. So that you have to take. So what is cutting speed? Cutting speed you have to take. If it is not given the cutting speed and some parameters you have to follow here. The what is n? Double strokes. If you have to calculate capital N here, you have to use the cutting speed formula. That is, cutting speed is equal to V is equal to capital N into L into 1 plus m by 1000. This is one of the formulas that is used for the objective type. So 1000 into 1 plus m. So here you just try to see it is 20. So yes, just try to take n is equal to 1000 into V. V is what? V is the cutting speed, 21 meters per minute. So here you have to observe carefully. So the L is what is L here? You just try to have this L. L is the length of stroke. Here L is the length of stroke into 1 plus 2/3. M is 2/3. So you have to take the standard notations into consideration, and here you have calculated capital N. So after calculating capital N, you have to calculate the time for calculation. So what is the nearest available lamp stroke? 40 strokes per minute. Out of all the 4 values, you have to take whatever 4 values you have given, because he has in the calculation you have got 42 strokes per minute, though he has given 4 values in the problem. What is the nearest value? You have to take the nearest value is 40, though he has given 28, 40, 60 and 90. So be careful while choosing the particular value there. So don't get confused as far as that. So the nearest available ramp stroke is 40 strokes per minute. So you have to take that. So that this value is correct. This value is correct. If this value is not close to all the 4 values that is given in the problem, that is not there. So that particular number of strokes should not exceed this 40. Should not exceed this particular specified cutting speed. Because if it is exceeding, already we have spoken in the first unit itself, it will affect the tool life. According to the Taylor's tool life equation, if the cutting speed, if you want to adversely increase the cutting speed beyond a certain limit, it will naturally affect the tool life. So we have to select the n is equal to 40 strokes per minute. So calculating this, TS is equal to 150 by 40. 150. What is 150 here? You can see there. You can see in the problem. By 40 into 2, double stroke, 40 into 2. So you are getting that as 1.88 minutes. So you are calculated here the machining time. Okay. So that you have to take into consideration. So just go back if you are having any problem. This is W. So you may be wondering why we have taken 150 there. 150 is the width. W by n into F. W by n into F. This formula, n into F. So double stroke, 2 mm per double stroke. N 40. Though you have got 42, it should not exceed 40. W 150. You have got 1.88 minutes. 1.88. So this is a very important problem rather than the other 2 problems we have discussed. So MRR, this formula already we have spoken of in the derivation. This 2 into 4 into 40 into 300 into 1 plus 2/3. This is M. So what is this 300? 300 is what? You just try to see. What is the 300? 300 is L, length of stroke, length of cutting stroke, length of stroke. And that MRR formula, I'll just try to show you once again. that MRR formula. You just try to observe this and we'll just try to leave in 1 minute. So what is MRR? MRR is nothing but MRR. Okay, we just try to have this in your PPT and try to solve this problems also. So if it is not unsolved in the, if it is unsolved in the PPT or PDF, you just try to solve this also. So what is this? You've got that as 1.88 minutes and try to substitute all the values, whatever is given, depth and everything. This is the number of strokes, this is the depth of cut, this is the feed into length of stroke, cutting stroke into 1 plus m. That is some value you'll be getting. You just try to see 1,60,000 mm cube per minute. So we'll try to leave here. If anything is there, similar problems are there, we don't repeat. Only you have to see about this one, the ratio of the cutting to return time ratio. You have to calculate or apply that in M or K, and the total clearance should be taken on both sides. That is the thing. And standard notations, if you try to follow as far as the length of cutting stroke. So just try to see this and solve these two problems, unsolved problems in the PPT. We'll leave. Okay. So Monday we'll start the drilling introduction. Okay. Thank you.